So let's talk about the projects, right? So on Blackboard, okay, I'm definitely recording that. Yes. Okay, so on Blackboard, you will notice that there is now a little click here for, where is it? Where is it? Exam 3 or project option. And if you click on that, where does that take you? Well, that takes us to exam 3 project option. It takes you to a description, exam 3 or project. You have the choice of completing a third exam, covering only materials since the second one, which is just correlation or regression. You may also notice that I put a brief assignment on here, correlation and regression. Okay, that brief assignment basically is just what we did in one of these examples, similar to what we just did in one of these examples, right? So that you can get a little bit of practice with it before the exam. Okay, and usual rules. It's technically due December 15th, which is like Sunday night or something like that, and at least the first submission. But you have until the end of the semester to complete it. Just keep in mind, the end of the semester is December 19th is the last day of finals, right? So I need it by then. Technically, I'll probably be doing the work on the 20th, so you guys can stretch it out to the 20th if you need to. But I have to get grades in, so don't stretch it too far. So this first attempt on the homework is December by December 15th. If you submit by December 15th, you can go back in the remaining week. You can go back and do it again, do the assignment again for an increased score. Okay, the assignment, as always, would give you tell you which answers you got wrong, but not give you the right answers. So you can go back there and take a look at it. Okay, so the project. So we have a little tab. Okay, so so option A is available now, of course. So option A is that project. So you have a couple of documents there. First document is a description of the project itself. Okay, so what do we want you to do? Okay, so we want you to choose from one of the data set that we've provided here, and I'll go back and show you what those data sets are. And we want you to put together a report. Now, keep in mind that if this were brick and mortar, I would be asking you to do a presentation that looks kind of like a poster presentation at a professional organization. For you guys that haven't seen this before, let's see, APHA, American Public Health Association poster session. Okay, let's see if I can get a couple of images here. Okay, so how's this look? Well, yeah, take a look at this. Many people present their research from a podium. They have lecture, like 3 p.m. So Dr. So-and-so or this researcher is presenting in conference room C from 2:30 to 3 o'clock. He's going to present his research on HIV and so on and so forth. Well, obviously, giant conferences like American Public Health Association, tens of thousands of people show up for, they don't have enough conference space for every presenter or every piece of research that might be important for people to see to be able to present it live. So they have large poster sessions. So basically what you see is, this one's a nice one, they got chairs. Usually don't have chairs. That you see is rows, literally rows. You'll see there's other ones here on the right, rows of these posters. They're professionally printed. We're not going to do that, obviously. They're professionally printed, but if you look at the individual posters, they outline a person's endeavors of research, what he's trying to show, how he's doing it, how he's collecting his data, what his data looks like, descriptive statistics on the populations that he's examining, for instance, his results of his research could include statistical tests, charts, and so on and so forth, and his conclusions and what he wants to do with this in the future, right? So all of that's kind of written very compactly and succinctly on this poster, so that people can walk down this aisle, glance at these posters, and if they see something that, for instance, I'm very much involved in Legionnaire's disease and cooling towers. So if I were walking up and down this aisle, I'd be ignoring the ones on HIV, ignoring the ones on nursing issues and so on and so. But if I saw one on Legionnaire's disease, I'd say, aha, let's see what this guy's working on, I would stop there. And in this case, for instance, you see the actual researchers that are standing by their posters, so someone can actually talk to them about that, ask questions, and so on and so forth. So that's kind of what we want your report to be. Like, what kind of thing would you put on a poster? And if you look, I can show you some examples of posters. You don't be surprised if some of these are students from Hunter, right? Because a lot of them do present here. So you can see that these are rather elaborate, right? But again, remember, this is presenting all their research. Okay, so this one includes a lot of graphics. Graphics are nice. Graphics tell you a lot of information at a glance, rather than have to get up close, and especially for a poster reading a table. Much harder to read this table than to read this graph, but you get the data presented in both ways. The table is probably more comprehensive, but the graph gives you a quick look at that information. So you might have an introduction into the research. You might have something about what the research question is. You might have the methodology. Here you might have the data, maybe some of these statistical results. Here you might have the results and conclusion, including, the regression analysis, the chi-square value, and so on and so forth. And down here you might have discussion, recommendations and discussions. And down at the bottom here you might have references, articles that are relevant to their research, that their research is based on, and that they use as part of their research, right? So these elements are the kinds of things that we want to see in the report. And you can see, even on this real professional poster, talking about 1, 2, 3, 4, maybe 5 type pages and some charts and tables. Yeah, kind of. Yeah, but you don't have to. When we were doing it brick and mortar, people would go to PowerPoint or something like that and print this out on a piece of paper, and then we would take a poster board and just tack them up. So it was literally would look like this, but like kind of like the kind of like a Frankenstein version of it, taped together and held up with tacks and stuff like that. But that's what we're driving. That's the kind of report that we're interested in. But the actual rubrics of the report, and again, you don't have to get crazy and make it exactly like a poster. Just we want to get that kind of, imagine that this is what you're doing. You're presenting this information to other researchers as they walk by, because you want feedback on this. You're going to continue to do research. You're going to want to go for grants and things like that, or extend your grant and so on and so forth. So you want feedback from other people saying, gee, this is really interesting. Did you consider this? Or this is really interesting. There's a guy over here that's doing this other part of this that you should get together with, right? So you want that kind of feedback. So what should the report contain? It should contain an introduction, probably like that was there. You should probably include some descriptive statistics. In other words, if you were using the data set that we were just working with today, that North Carolina birth, the descriptive statistics might be the distribution of the age of the mothers. It might be a histogram showing the birth weights of the infants. It might be a bar chart showing how many mothers smoked or didn't smoke, how many mothers drank, didn't. So you might have you might have some statistics there to show us, give us a picture of what the population looks like, some descriptive statistics, right? And including the variables, especially the variables you're looking at. You don't have to get crazy about that, just something very simple, right? And you could do that in Excel, you could do that in SPSS, right? A lot of ways you could do that. Section number 3 is the methods. Okay, how was the data collected? What are the variables? What are the units of the variables? And how did you analyze the data? What statistical tests you used to analyze the data? Section 4 is the results. Show us the tables that you got, your chi-square table, your scatter plot for your correlation or regression, and so on and so forth, if you wind up doing something like that. The results of your t-test, your analysis of variance, your post-hoc tests, and so on and so forth. And then finally, the discussions and conclusions. Now, you should also include at least I think it's up here. It should also include, I want to make sure it's on here somewhere. Okay, other variables. Should also include, I'm going to add it, I'm going to add it there, but you should also include at least one or two references that are relevant to the variables that you choose, the data set and the variable that you choose to work with. So for instance, if you decided that you're going to work with, you have your own data set that involves the diabetes and the amount of exercise a person gets, you might want to give us an article that you found on PubMed. We have access to, hopefully the library, you guys are trained to use the library and stuff like that, and go on PubMed or one of the other databases that we have and see if you can't find an article that relates to what you're doing in your analysis, right? And include at least one or two relevant articles at the end of your post. So I'll add it on as 6, one or two relevant articles and so on. So what are your options? Well, one option is that you do an analysis based on flu shot utilization in New York City. If people that are more insured, more likely to get flu shots are people that are native born to the United States, or different boroughs have different rates, so on and so forth. But how are we going to do that? Well, we've given you data here from the New York City Community Health Survey. We discussed that last week. And this data, we gave you several different versions of it. One of them is the full data set for 2013 with all of the 200 questions that they asked in this survey and so on and so forth, and the code book that has all of that data. Well, what we did then is we took a subset of that data that was relevant to influenza. Okay, so, and you have 3 versions of this, and one of them is the actuals as a subset of the data from that year, from that survey for that year, that that has, I think it's 8 or 9 variables, and it's already coded. Now, you don't have to use this data set. I'm going to put it on my desktop. You don't have to use this data set, right? But you're welcome to it. Let me just open this again. I think in here I have, do I have it? There you go. These are the variables in that data set: flu shot, health insurance, race and ethnicity, borough, neighborhood, the rate of poverty in the neighborhood where they're located, their gender, their age, whether or not their nativity, whether or not U.S. born or not, and if they have any, if they're children in the household, and so on and so forth. And you can look at this and see which of these one. It doesn't have to be all these variables. It could be only a couple of them. You might want to look at the impact of health insurance on someone getting a flu shot and what borough they live in, or health insurance and the rate of poverty in the neighborhood they live in. Or you might want to look at the likelihood of getting a flu shot and what person's age is, and so on. So you can combine a couple of these. You could do a couple of analyses. You could do just one analysis. It's up to you. And this data set has already been prepared for you, coded and everything. I'm about to open it up now so you can see it. Okay, so now you know what happens. The Olympics are in Tokyo next year. And I just read an interesting article today because the World Sports Organization, which everyone that generally sanctions all of these different countries' sports groups, is it possibly going to rule to forbid Russian athletes from competing in any international events for the next 4 years, which would mean that they would miss the Olympics in Tokyo, and that's because that they've been caught repeatedly cheating on drug testing, on doping and drug testing, and not individual athletes, as an organized cheating on those tests, and so that they're kind of in big trouble. But the reason why I brought up the Olympics is because the Olympics, when you are a diver, right, Summer Olympics, when you're a diver or you're doing one of these other sports that are judged sports, right? Well, you got two elements there. You have how well you perform, and you have the difficulty of your program, right? So if you are going to use my coded data set that I've done that all that work for you and it's all like laid out for you, that's great, right? But you'll be judged a little bit more harshly than if you decided to go into the code book and go into that full data set and find a couple of your own variables. You get a little bit more creative. Then I'm not saying that I'll grade you. I'm not saying that you're going to be penalized for using the data set that I prepared for you. But I am saying, what I'm saying is more likely that if you make a mistake on a data set that you put together yourself and you coded and so on and so forth, I can give you a lot more latitude on that because you kind of went out of your way to like really stretch yourself and learn a bit more about how to do this stuff. Okay, so it's not so much I'm going to grade it more harshly. It's that I'm going to grade the other one more little bit more with a little bit more understanding if you do something that requires you to go a little bit out of your way and do something a little bit more adventurous. Okay, so so that's the particular data set. So now also let me just open this other data set. Okay, open data, navigate to where it is. Here's our simplified flu data set. And the variables I just mentioned here were in the data view. Here's the variables. Demog1 happens to be age, the age of the person. I don't know why they gave it that variable name, but again, you can see why we like using those labels, right? So what is that Demog1? It's the subject's age. Borough is borough residence, a little bit easier to understand. And you'll notice I also coded in the values for you. Like for the borough, I've coded in what those values mean. So this really is prepared for you to go ahead and work with this and decide, well, I want to work with the borough and whether or not, I want to work with the borough and whether or not they got a flu shot in the past 12 months, right? Maybe I have a feeling that people in Manhattan may be more likely, more affluent, may likely to get flu shots or less likely to get flu shots. Busy or less likely to get flu shots. You might examine that relationship, right? In other words, there's two nominal variables. Each of them are categorical, right? And you have 5 categories for the borough, and you have 2 categories for whether or not a person got 2 values for a person got a flu shot or not, right? So what is that? That's 5 by 2. That's chi-square, right? You're gonna have a contingency table. Boroughs, 5 rows, boroughs, and 2 rows got a flu shot, didn't get a flu shot. So you can do a chi-square analysis to see if there's a relationship between, if there's a significant difference between which boroughs you live in and whether or not you get a flu shot. You can also, perhaps, if you get a little creative, you can maybe create or transform or create a new variable. Maybe I'll do that on Monday, show you. We did it last week. Maybe I'll redo that on Monday, show you how to transform a variable or compute a new variable, create a new variable. Maybe you can create a new variable where you can compare, where you can accumulate all of the boroughs together. And so that you can individually look at the rate that people in Brooklyn get a flu shot versus the rate that people in the entire city get a flu shot. So it would be a 2 by 2 table, borough, Brooklyn, and the entire city. So that 2 by 2 table, you could do an odds ratio for. And then you could repeat it for Bronx versus the entire city and Queens versus the entire city. So you can get an idea of which of those have a higher rate or have higher odds of getting a flu shot if they're in that particular borough versus the rest of the city. Okay, so I can show you how to lay that out. Okay, so we'll talk about that possibly on Monday, but you already have a lot of variables you can work with already. So now let's say you want to get a little bit more adventurous. You want to get a little bit more adventurous, we have, let me go to Blackboard again. We have also other data sets here. We have data from the Framingham study that involved doctors, and it was an extended study, a prospective study where they followed tens of thousands or thousands at least of doctors to determine which ones would eventually develop heart disease and so on, cardiovascular disease and so on over a period of time, which of them smoked and so on and so forth. So you have data from that study here. You have a study on digitalis. You have a study on physical activity and the transit system. Yeah, you have several other data sets that you might want to look at. This one involves New York City youths, and types of risky behavior that they might be involved in. Okay, and but you might want to consider taking a look at some of that data, and you can also use some of your own data if you're working in another course and you have a project you're working on. I have no problem with you taking the data that you're using in that other course and using it for this project, doing an analysis using SPSS, using one of the techniques that we've learned, and submitting a project based on that. Okay, so let me just show you the entire data set as an SAV file, save as. Okay, and I'm gonna go here, say file, open data. Oops. Simplified. Here's the full data set. Okay, here's a whole bunch of numbers up there, right? So for instance, mood 1, a whole bunch of numbers in there. Well, obviously you don't know what mood 1 is. All you can see are those numbers. So we go into the variable view, see mood 1 here. We can see a label that has carried over. And that label, oops, let me undo that. That label tells us that that question was, during the past 30 days, how often did you feel nervous? Right, mood 2 is that particular variable. What is your age? Demog 1 is what is your age, and so on. Okay, so that's very nice for what is your age, because that's a numerical variable, right? But for instance, if we go here to borough, for instance, which is already in the other database, borough of residence, right? Okay, so that makes sense. That's a borough is borough of residence. But if we go over to values, it's not coded. It doesn't say what each of those numbers, what 1 represents, 2 represents, what boroughs they are. So where are you going to find that information so you can add it to these values? Well, I've also given you a code book. And in the code book, if you open the code book, you can look up what the variable borough, what the values are for the variable borough, if I spell it right. Okay, here's boroughs. Let's see if I can find the variable. There it is, variable borough. And in that variable, 1 represents the Bronx, 2 represents Brooklyn, 3 represents Manhattan, 4 represents Queens. So we can go back to that variable and we can code that information into that variable, okay, as you've seen us do before. In other words, go in here to our variable view and tell it that for borough, what did I say, borough here? See if I can't find it again. For borough, if I go into values, now I can tell it that 1 represents the Bronx. I covered it now, so I'm not sure what it is, and 2 represents Queens or whatever. Right? I don't know that that's exactly right because I covered it up. Maybe I can get it to scroll down. Up 1 is Bronx and 2 is Brooklyn, and so on. And you can code all these things. And they have information. They have variables in here when they ask, where they ask people about their consumption of fruit, about whether or not they've had an asthma attack, whether they've been told that they have diabetes during the past 12 months, type of health insurance that they have, so on and so forth. So you can see there's a lot of different elements to this particular survey. And you can just pick out a couple of these variables and say, gee, I'm really interested in smoking status more than anything else and how it affects a person's health. So maybe, or maybe how it's distributed in the population. are younger people smoking more than older people are, for instance. So you can develop your own study, your own poster project, and put it together and submit it as a project. Okay, and that's for you guys that are adventurous, don't mind taking a little bit of a chance, that want to be judged a little less rigorously, right? But you guys, if you're nervous about that, you don't feel comfortable with that, you can use the prepared data set that I gave you. And all these reports are your own work, so there's no right or wrong answer here. It's basically take the tools that we've given you and take the data that sounds most interesting to you and do something interesting with it, do something creative with it. Okay. Okay. So let's stop there. And on Monday, this coming Monday, the exam and the exam will be available. As of right now, you have the information you need available for you to work on your project. The exam will be available by Monday. I'll probably get it up a day or two before. So if you check Blackboard over the weekend, I'll probably make it available a little sooner. Both of them are due by December 19th. If you're really stuck, I can stretch a day, but I need to get all the grades in so I can work on them over the weekend and get them inputted.